Cities and heat. Deserts are hot. The world is getting hotter, and cities in particular are getting hotter. And surely we, as architects and town planners, can do better than glass boxes in concrete jungles. My name is Evyatar Erell. I'm an architect and an urban climatologist at the Department of Geography and Environmental Development of Ben-Gurion University in the Negev in Israel. Let's begin by agreeing on common objectives. Indoor comfort. We want to be comfortable in the spaces we occupy 90% of the time. We also want to be comfortable outdoors when we go outside of our buildings. And we need to do that whatever our activities are, whatever the cultural norms are, whatever our individual preferences are. And we want to do that in a sustainable fashion. These are our objectives. Now note that I have not mentioned buzz phrases such as urban heat island mitigation, which are common in the planning community. I'm talking about the basic requirements. What is the urban heat island, which is mentioned so often? On the left-hand side of the slide, you can see a thermal image from a satellite of the city of Beersheba taken at night. You can see the city appears as a warm red blotch against the blue background. And the visual image of the city on the right, you can see areas marked in a red rectangle and a red circle, just to get you fixed in terms of your coordinates. This is a thermal image of the exact same location during the daytime. And notice that it is almost the exact inverse. The city is cooler and the desert surroundings are warmer, with the exception of that small patch inside the rectangle, which is an irrigated field. So deserts are different. And it may still be very hot even if there's no daytime heat island. So let's look at what we can do about it. The traditional response, we are led to believe, is narrow alleys. It turns out, though, that urban climatology shows us that the intensity of the urban heat island at night is related to how dense the city is. We measure the density of the city by the ratio between the height of the buildings and the width of the streets. So in our case, H over W is equal to about 2, and that would correspond to the maximum intensity of the heat island at night of over 10 degrees centigrade. If all we did was make that street broader, say 15 meters for the same height of buildings, the maximum heat island intensity would only be about 4 degrees. So worldwide, urban heat islands occur at night, and narrow alleys, the traditional desert response, actually makes them worse. Well, how about green roofs? We've all seen images like this, in this case, a photograph taken from Freiburg in Germany. The only trouble is that if it doesn't rain, a green roof will require irrigation to remain cool. So yeah, deserts are different, that's obvious. Well, how about the traditional Mediterranean response? A whitewashed roof. That actually works pretty well, except maybe let's replace that boat with photovoltaic panels to generate electricity. Well, okay, if the roofs have got solar photovoltaics, how about high albedo roads? Let's paint the roads white. So in fact, this is being done in some cities around the world, and you can see a crew here painting the pavement white, if you like. It turns out that if you are a pedestrian, if you're walking along that street, you'll actually feel worse. You'll actually feel hotter on the white street than on the asphalt street, and this is counterintuitive. I realize that. But that is because the sunlight has got to go somewhere. It's reflected from that white surface, and you're absorbing all of that reflected sunlight. So you're actually exposed to more heat, even though the air temperature is lower. So increasing albedo does not improve thermal comfort in hot weather. Let's go back to vegetation, except not on the roof, but in a courtyard. And the chart here shows us that just replacing a bare concrete and soil surface in a courtyard with grass will make you a lot more comfortable. The chart shows the time of day on the horizontal axis and the thermal stress on the vertical axis. So the higher the line on the chart, the hotter you're going to feel. Green is good in this case. So grass helps in exposed spaces. Well, we can do better than that, because if we add shade instead of grass, and the shade can be trees or it can be a shade mesh, and we add grass in addition, we're doing better. So grass helps, but shade trees are much better, and they need less water. So there's a benefit for you in the desert. So looking at vegetation in dry cities, we want to keep it limited in extent because we don't have too much water. We want to provide shade, that means trees, and we want to provide it where people are. Not on the roofs where there are hardly any people, but where people are actually spending their time walking, jogging with friends, and so on. As for the buildings, we want them to have layered facades. By layered facades, I simply mean the traditional curtains on the inside. They can be Venetian blinds, then the glass, then external shading, and this is a pretty old-fashioned sort of example. You can have the mashrabiyah, the beautiful Muslim Arab solution to provide shade, or you can have the modern approach with what is known as a double-skin facade, in which you have two layers of glass, and in between them, some sort of shading element, which can be a fabric or Venetian blinds in this case. At street level, you want arcades. Again, the traditional response, this case, representation of the main shopping street of Jerusalem in Roman times, the Cardo. You could have a traditional European response, this beautiful arcade from Portugal. You can have a present-day response, which is from the city of Beersheba, or what it might look like in a rendering of the future, this beautiful streetscape which has the arcades, has shaded areas, in addition to some vegetation. So what is my take-home message? Consider that person looking for their keys under the lamppost. The keys are obviously not there. They just dropped them someplace else, but they're looking under the lamppost because it's convenient. So let's start off by asking the right questions. Not necessarily the questions to which the answers are easy, but the ones which are most appropriate. Then we can send appropriate objectives. And we need to set the objectives for urban planners, not for researchers, for people who actually need to apply the knowledge. Finally, even though the answers may be complex or even contradictory, we need to be able to integrate them into the design, and that is something for the planners and architects to address. Deserts really are different. We need solutions for deserts, and knowledge and technology can provide them. Thank you for your attention.